Good morning, everyone. Thank you for joining me today. We have discussed about schedulers, which is capacity scheduler, phase scheduler, first in first out scheduler. So default schedulers varies from Cloudera to Hortonworks, and if it is plain vanilla Hadoop, also the characteristics and the features of the schedulers varies. Okay, so let's just recap. We have been discussing on SDFS. We know what is yarn, we know what is map reduce, we know what is map task, we know what is reduce task, and we know what is intermediate stage of map reduce task. So we also revised that in Hadoop 1 it was MR1, later it is MR2, and an advanced part of processing framework is yarn. So, in continuation with that, today we are going to learn how well can you tune yarn, which is called yarn performance tuning. Okay, this is very important, very important. Definitely in the interviews they'll ask you what level of expertise do you have on yarn performance tuning. They may put these questions in different ways. Have you ever worked on optimizing your production jobs? My jobs are running very late. How do you optimize it? My production cluster is running very slow. How do you improve the performance? And my environment in the cluster is very slow. How do you optimize it? Anything they ask you optimizations, the first area you need to focus is yarn, because SDFS, if you have SDFS, what we can say, yeah, there are a couple of compressions in your HDFS, snappy codec compression and all these things. If you implement that compression, that is one area of it. Yeah, let's understand thing practically. HDFS part of it, if your blocks are replicated properly, if you have very less under replicated blocks, and also if your data nodes are healthy, your HDFS is highly performance oriented. Like that, yarn also has got set of things which you must know so that you can focus towards performance tuning. That is the importance of today's class. Okay, now let me go to the agenda. If you see here, understanding the important conceptual and architectures of yarn and schedulers, provide a basic understanding of components that make up yarn. All these days we are talking about yarn. Today we are going to understand what is yarn made up of. Okay, what are the components that really make yarn? What is the important features of each and every component? How each and every component are interrelated? What happens if any of one component doesn't work properly? This is the root, and we are going to nail it down. Okay, illustrate how a map reduce job first fits into yarn model of computation. Guys, having said, Hadoop is storage and computation. Forget about Scoop, Hive, Kafka, Flume, HBase, Spark. Forget about all these things. First basic thing you have to highlight is storage, which is HDFS, processing and computation, which is MapReduce 1, MapReduce 2, Yarn. Or you can say Yarn now. Okay. Now, how well can a MapReduce job fit into Yarn model of computation? That's all we are going to learn. Now, one important note you have to highlight here is, although Apache Spark integrates with Yarn as well, this series will focus only on MapReduce specifically. I repeat, somebody may ask you, and even I have faced this question many times. Your Apache Spark is very well integrated with your Yarn. When you are running a Apache Spark job, okay, when you're running an Apache Spark job, that job statistics, created time, submission time, running time, status, amount of resources it is utilizing, everything can be looked at can be identified from yarn resource manager. Please be aware of it. Now we are going to present an overview of yarn scheduler works and provide a building blocks for the scheduler configuration. This demo is broken into pieces. The first one is what is a cluster, what is yarn and its basics, global configuration basics. Global configurations mean not specific to one node, it is specific to the whole cluster. Okay, now understanding scheduler concepts, phase scheduler queue basics, and using phase scheduler queue properties. Yesterday we understood something about we understood about uh, uh, configurations of phase scheduler, how to enable phase scheduler, and how you can get the best performance out of it. Today we are going to enhance that one. Okay, now let me go back here. See, one thing guys, look at the diagram. Look at the diagram. Try to understand what I'm telling. The resource manager is the master daemon. Resource manager is your name node, job tracker, and your task tracker is on data node, which is also called as worker node. So this line here means your resource manager is the master daemon. Daemon is nothing but a service that communicates with the client, tracks the resources on the cluster, and orchestrates the work by assigning tasks to node manager. Let me tell once again. Job tracker, name node. Task tracker, data node. Like that, resource manager on the name node, masters, and node managers on the worker nodes or data nodes. Once again, once again, job tracker, name node. Task tracker, worker node. Resource manager, name node. Node manager, worker node. In MR1 and MR2, you have job tracker and task tracker. In Yarn, you have resource manager and node manager. Hope you got the interconnectivity of it. As the as the as the MR1 enhanced to MR2, and when in MR2 when Yarn is incorporated, there is an additional feature came up, which is working like job tracker as resource manager, task tracker as node manager. That's it. Now let's understand what a node manager is. A node manager is a worker daemon that launches and tracks the process spawned on worker host. In worker host is nothing but data node. You very well know whenever a MapReduce job is running, the MapReduce job checks for the nearest data node where data is available and runs the task tracker there. So this task tracker is managed by the node manager. So node manager is a worker daemon that launches and tasks the process spawn on the worker host. Hope you're clear. Now, the yarn configuration file is an XML file that contains properties used to configure resource manager, node manager by default. This is called yarn_set.xml. If you remember carefully, yesterday I have shown you map_set.xml, yarn_set.xml. In yarn_set.xml, you define your job tracker, task tracker. Like that, you also define your resource manager and node manager. Where is the XML file found? It will be in etc hadoop conf. In that, you'll have yarn_set.xml. Clear, everyone? Let me move on. Now, Yarn's vCore and memory. What is a virtual core? What is a memory? Very, very careful. Look at my diagram on the right hand side. You have a master. You have a resource manager. Your resource manager has virtual cores of 6. You have a resource manager of virtual core 6400, and you have a RAM of 12,800 GB. Okay. Now go to your worker node. In your worker node, you have a node manager. You have virtual cores of 64. You have RAM of 128 GB. See, in each worker node, you have 8 by 8. Means CPU 8 by 8 means 8 core process and you have 8 CPUs. Like that, you have 128 GB. Like that, you have 100 worker nodes. Each worker node or each data node is made up of 128 GB of RAM and 8 core process, 8 CPUs, or 8 by 8, you can say that. Okay, node manager, you have 64 virtual cores. Guys, try to understand your physical CPU and your V cores are different. Your V cores means your CPU strength into number of threads uh, it can release and act accordingly. Okay, let me show you that. It's very important to understand difference between. I'm sorry, I don't know why I'm opening the email. Sorry for that. I'll explain very clearly difference between physical memory. Somebody has asked me also already. Understand difference between CPU and V cores. I'm not able to explain the exact sentence. That's the reason why I'm just coming to here. See, see here, a core is usually a basic computation unit of a central processing unit. Perfect. It can run a single program context or multiple ones if it supports hardware threads such as hyperthreading or Intel CPUs. Maintaining the correct program state, registers, and correct execution orders, and performing the operations through ALUs. For optimization purpose, a core can also hold on core caches with the copies of frequently used memory chunks. Okay. Now, for example, you have a CPU. In CPU, you have cores. Core is nothing but it's usually a basic computation unit. The combination of computation units comprises a CPU. Now, whenever a single program is run with context with a single thread or multiple thread, it supports a hardware thread such as hyper-threading or internal CPUs. Hyper-threading means you have a CPU, you have a central processing unit, and for one activity it releases one thread. That is called processes. Process is different, processes is different. So you're running on one work. For your work, CPU has dedicated one process. You other person also launched another task that is also picked up and it is trying to run. That is other process, and there's one thread dedicated to it. This process one, process two, thread one, thread two made is called as processes. This processes is hyper-threading, means using resources very effectively in terms of giving high performance. Now, a CPU may have one or more cores to perform tasks at any given time. Fair enough. It's a very straightforward idea. Now, these tasks are usually software processes and threads that OS schedules. Note that OS may have threads to run, but CPU can only run X such task at given time. X equal to number of cores into number of hardware threads per core. There is this is also interview question. In the capacity planning, they'll ask you something. On what basis do you do capacity planning? On what basis do you recommend for your business this much of CPU is required, this much of memory is required? So you will get that idea only if you understand this basic, which is nothing but tasks are usually a software process threads that OS schedules. Perfect. OS may have many threads to run. Got it. But CPU can only run X such task. X such task is nothing but number of cores into number of hardware threads per core. So if you have 8 core processor, if you have 8 core per processor, for that 8 core processor to be efficiently running, for each core, how many threads is it releasing? how those threads are hyper threading, how the process thread and processes are working. And other end of the coin or other side of the coin is you have 8 by 8 core processor, but your hardware components are not supporting that 8 by 8 processor. There's no part in maintaining it. There's no profit in having 8 by 8 core processor when your hardware components are not supporting it. So it is a combination of win-win situations. Your processor should also have enough boosting from your hardware components, so that the X means number of cores into number of hardware threads. Okay, that's all it is. That's all it is. Super. See the example. If you have Windows user, you can see that. If you go to your CPU, you will see how many cores. 4 core processor. Logical processor is 8. Means it's 8 by 4. Within your 8 process, within your 8 processors, it has 4 cores. So one core can have launch multiple threads. It can support multi-threading. Okay, that is the concept of it. This is enough to understand what is course and what is physical. Okay, if anybody asks you, you must be able to answer it carefully. Everyone happy with the explanation? Any questions till this point? Quick. I have 6 members in the class. There's no response from others. Perfect. Okay, now try to understand it, guys. If you don't understand difference between CPUs and virtual cores, there is no point in moving forward. Any sort of confusion, if you're not clear in any area, let me know. I'll try in a different way. But you have to understand difference between, because throughout the slides today, your visual course keeps haunting you in your subconscious thing. So please be very careful. Try to understand it. When I'm rubbing something very hard, there is a reason behind it. So I want to ask you, if you don't understand the difference between CPU and V cores, stop me. Okay. Thank you for that. Hope you are all clear with that. Okay, that's all right. That's all right. Now, yarn currently defines two resources. If you remember earlier, మనకి ఎలాగైతే ఉండడానికి ఇల్లు, కట్టుకోవడానికి బట్ట, తినడానికి తిండి కావాలో, లిటరలీ your task, your yarn to launch needs memory and CPU and storage. Storage is to store the processing work logs, or to write what is happening while it is processing. That is storage. CPU is to process, means పని చేయించడానికి. Okay. RAM is to live on it, is to protect itself. That is the importance of it. Okay. Storage, processing, memory. Storage to write the logs or write the processing details, when started, what started, how it is progressing, what is happening, that one. Processing is to process, means to do the work, and RAM to protect itself. That's how I remember, and that's how I'm telling it to you. It may, your interpretation may be different. The way for you, how the food, home, and clothes are important. For yarn, the CPU, memory, and storage are also important. Just remember that. Now, yarn currently defines two resources, that is vCores and memory. Each node manager means worker nodes mean task tracker. Each node manager tracks its own local resources and communicates it to resource configuration to the resource manager. Means your task tracker talking to job tracker, your node manager talking to your resource manager. Perfect. What is it talking about? It is talking about resources available. It is talking about tracking the resources. It is telling about the submission details. Now, resource manager, which keeps running of total cluster available resources. Fair enough. Very good idea. Now, virtual core has a special meaning in yarn. Okay, you can think of it as a simply usage share of a CPU core. Having said, if you have a 8 processors CPU with 4 core, which means each core will have a multiple threads or processors released to increase the performance part of it, which is called hyper threading concept. Don't go beyond this at the moment. That's more than enough, and that's what you need to understand. Okay, if you go deep into it, you'll tend to confuse. All you need to understand is what is CPU, what is virtual cores. So virtual cores for this yarn means it is a subcomponent or it is a usage share of a CPU core. Very good. Now, if you expect your task to be less CPU intensive, sometimes called as input output intensive, you can see the ratio of virtual cores to physical cores higher than 1 to maximize your use of hardware resources. So if you remember just 5 minutes back, I told you, if you have an awesome processor and very large number of cores, and if your hardware components are not supporting that, or if your hardware components are not using that properly, your virtual cores will not work as the way desired to, which means there should be a proper coupling of hardware components to your physical CPU and virtual cores of the CPU. How is that can be done? That can be done with, you can set the ratio of V cores to physical cores higher than 1. Okay, I'm going to show that practically next slide. Don't worry about it. One thing you have to remember here is the ratio of physical cores or the ratio of virtual cores to physical cores must be always greater than 1. Why? To maximize your hardware resources. How are you benefiting here? You are benefiting here because it will have very less input output. It will have very less IO intensive. That is the ideology of it. I hope this is also very clear. If I am not clear, stop me please. Now, you understood the diagram here? Your master 1 is coordinating with worker 1 to worker 100. If you see, master has got 6400 virtual cores, okay, and your worker 1 has got 64 into 100 is 6400. 8 by 8 means 8 process with 8 core, so 64 into 100, 6400. That is the master and worker node configurations. A sample I can say. Now, containers of a yarn. Guys, what is the meaning of a container? Container contains something. Got it? The same thing. Containers are an important concept of yarn. Container is a request to hold resources for a yarn cluster. Currently, a container hold request consists of vCores and memory. Try to understand, it is not holding a physical memory, it is holding a virtual core memory. Okay, container is nothing but a two-line word. Container is a request. Container is a request to hold resource on your yarn cluster. Currently, container hold request consists of vCores and memory. Container. Look at the diagram now. You understood the theory? Look at the diagram. Container on the left side has a virtual core request 1 and memory request of 8 GB. Now come to right side of the diagram. Container, you have request 1, you have memory 8 GB. Within that 8 GB, see your core. Your code is using CPU, your code is using RAM, your code is using HDD. HDD is nothing but hardware disk drive. Okay, clear? Clear the container, guys. Big containers carrying carts from one country to other country, or a warehouse containers containing company's logistics, like that. Your yarn container is a request that is containing your RAM and V codes for your activity, for your task to complete. As simple as such. Now may understand the link. Once a hold has been granted on a host, means when I launch my task, when a thread is requested, when a thread is active between me and cluster to complete a task, the node manager launches the process called a task. Very good. I have been telling this. Task tracker, job tracker. You submit to job tracker goes and finds a nearest task tracker, and task tracker will launch a task. Like that, once a request has been held here, held means not stopped, it is holded. Once the request is holded, what happens is there launches a task. When a task is launched, it is hungry for the resources. God's sake, you are asking me to do a task. I can do it, but how can I do it? I need memory, I need visual codes. There comes the container. Okay, for your task, I am requesting resources. I got the resources, this much of RAM, this much of visual codes, this much of HDD. Now I am putting this in a container and I'm giving it to you. My dear task, please tell to task manager and report to job or task tracker to job tracker, or node manager to resource manager, that you are connected, you are active on this task with the container. That is what it is going to do. Clear? Once again, I repeat. Once a hold has been granted on a host, the node manager launches a process called task. The right side of the figure shows a task running a process inside a container. Inside a container. Inside a container. Figure right side shows a task running inside a container. Got the idea, right? Very good. Now, running process and application masters. Now, an application is a yarn client program that made up of one or more tasks. Okay. Now let's form the link. The link is, you have a request, I got it. For your request, there is a task, I got it. Your task is memory hungry or resource hungry. Your task will ask, boss, you gave me task. Okay, boss, I'll do it. But I need resources. What you will do? Once the request is placed, your request will get a container. What is happening within the container? Inside the container, the task is running. What happens if you have hell lot of tasks like that? That is nothing but application. An application is a yarn client program. Yarn client program. When I say client, it is at the data node end, worker node end, task tracker end, అటువైపు వర్కర్ నోడ్ వైపు జరిగే అన్ని clients. Okay, remember that way. An application is a yarn client program that is made up of one or more components. Fair enough. Now, for running each application like that, I'm here, guys. I'm here. For for running each application programs, a special piece of code is required that is called application master. Okay, which helps in coordinating tasks on yarn cluster. The application master is the first process that runs when after the application starts. Now, you know what is a task? You know the combination of tasks are application, and application is the application is the yarn's client program that is made up of one or more tasks. Now, whenever an application is started, an application is a combination of tasks. Whenever an application is started, the application master is the first process that runs after application starts. Guys, try to understand something. Submitting the application is different, running the application is different. Once your application is submitted, the application master is the first thing that runs in the background. Okay, the application starts and talks to resource manager for the cluster. The resource manager makes a single container request on behalf of the application. Now, application master starts running with that container. What happens inside the container? Your task will be running inside the container. What is application master? Application master is the combination of tasks. What happens when the application master is running? When application is running, when application is started, in the background, application master is the first thing that is invoked. When it is invoked, it talks to resource manager. What it talks to resource manager? It asks for the resources. Now the resource manager gives a one container to the application master. That container, within that container, your task will be running. That is the flow of things. Now look at the diagram. You have client, which is application process. You have master, which is a resource manager. Now, when your application is submitted to master node, it is taken forward to worker node, and inside the worker node you have a container, one container with visual core request 1 and memory of 8 GB, and inside that the task is running. What is task using? Task using CPU, memory, and HDD. Now, the flow of work is application which you are submitting. It can be me, it can be application, it can be HBase, it can be Spark, it can be Scoop, it can be Flume, it can be Kafka, it can be anything. They are applications. When these applications are submitting a job, it first goes to master. Master then coordinates with worker. Okay, now I got resource manager, I got node manager. Now to run this, I need a container. Who is going to get the container? Application master gets container. Once container is provided, your task will start running with the available resources within that container. That's the ideology. Now, other diagram, carefully observe. The application master, the application master requests subsequent containers from the resource manager that are allocated to run the task for the application. Understand, understand. For example, for any reason, you have given X amount of containers. For some reason, that X amount of containers are not sufficient enough for the yarn to process. In that cases, the application master will request subsequent containers from the resource manager that are allocated to run the task for the application. Those tasks, those tasks do most of the status communication for application masters. Okay, now once all the tasks are finished, the application master exits saying bye bye. The last container is deallocated from the cluster. Now when the application master exits, the application master launched in a container is more specifically called as managed application master. Unmanaged application masters runs outside of yarn's control. Now look at the figure. You have application, you have application master, and you have task running with multiple containers running on the cluster. Have a look at diagram on the left side. You have client. Your client is nothing but your job who is submission, that is talking to your application master, and from application master you are going to your worker node. In the worker node you have a container. Okay, in that you can see a task running in multiple containers. Okay, guys, observe earlier. 1 minute, I'll show you that. In this diagram, let me take a pointer to make the difference look clear to you. Take a pen. If you see here, you have one container. Okay, this one container will have this much of memory, this much of CPU, this much of HDD. Okay, using this one, it is running a process, it is running a task. I'm happy, I don't have any questions on that one. Okay, now I'll erase the drawing here. I'll go to pointer. If you observe carefully here, this one, see, you have container. Okay, you have virtual Vico request. Here you have application master. Okay, that is the reason why we are telling a task application plus application master plus task running in multiple containers running on the cluster. Multiple containers means this is one container, this is one container. Like this, when you have 100 worker nodes, you have 100 containers running together. Okay, your application master is the one that is requesting the containers for you. That is the concept of it. Are you clear till this point? Any questions, please give me a shout. Let's not proceed if you don't understand anything here. Please don't waste my time. Quick. If you understand, say yes, understood. If you didn't understand, say no, I'll explain it again. But please don't waste my time. Hemant, Naresh, all okay? Did you understand carefully? Can we have more than one container in each worker node? You can have. You can have. Okay. Till here you are fine. Now let's go to next one. Let me raise the pointer. Perfect. Cool. You got it right. Now let's go next slide. Now observe this one. MapReduce versus yarn. In MapReduce process, paradigm is process. In MapReduce process, an application contains a map task and reduce task. Map task and reduce task align very cleanly with yarn task. Very good. Fairly straightforward. Nothing to confuse. Now, in MapReduce application, there are multiple tasks, each running in a container on a worker host somewhere in the cluster. I told you this many times. Okay, just to resurface. In a MapReduce application, there are multiple map tasks. This multiple map task will be running inside a container on the worker host somewhere. Very good. Similarly, there are multiple reduce tasks also running in the container on the worker host. I agree with you. Simultaneously means adi jarugutunnattugaane you have a yarn side. The resource manager, node manager, and application masters work together hand in hand to manage cluster resources and ensure the task as well as corresponding applications finish correctly. Now look at the diagram. You have a client, you have a master. Your master is talking to your worker node 1, worker node 2, worker node, like that. In each worker node you have a container. Okay, in that container you have a virtual container or virtual course memory, and within that your map task, reduce task, or application master task, or whatever they are running logically. Okay. Now, ideal production yarn allocation. Okay. Ideal production yarn allocation. Focus, guys. Please focus. In reality, there are two reasons why the full set of resources on a node can be allocated to yarn. I repeat that. In reality, there are two reasons why full set of resources on a node cannot be allocated. Cannot be allocated because it's not just yarn. There are so many other components running on your cluster. It can be SDFS, it can be Scoop, Flume, Spark, Kafka, HBase, Nox, Ranger, many things. Now, non-Apache Hadoop services are also required for running on a node overhead. Okay, if you remember this one, guys, if you remember this one, this is nothing but, this is nothing but, let me show you. Guys, I'll increase the font. See, this diagram I explained earlier, you remember? This is nothing but this one. However, we'll just do a quick revision. There are two reasons why full set of resources cannot be allocated to yarn. Because apart from yarn, there are lot of non-Apache Hadoop services also requires memory and CPU. They are also processed like yarn. When they need memory, you'll also have to give memory to them. You cannot allocate all the memory to yarn. Very good. Now, operating system overhead is nothing but any node any node needs an operating system in order to work. As I told you earlier, if you have 16 GB of RAM, you give at least 2 GB of RAM left for operating system. Okay, once that 2 GB is left to operating system, remaining you can allocate based upon your necessity and need. That is what it is. Now, this is called as overhead because this is definitely something you have to consider, right? Like that, other task overhead means if there are any custom programs that are persistent on worker nodes, you should set aside some resources for them. For example, you have cron jobs. For example, you have some operating system level things that are working. For them, you have to give some memory. And apart from Hadoop, if you have Tableau, if you have ClickView, or if you have something, you need to dedicate memory for them also. Very good. Cloudera manager agents, administrative. Like the way your operating system requires your yarn and operating system requires memory, your Cloudera manager is nothing but Cloudera's cluster management tool for Cloudera distribution of Hadoop. A Cloudera manager agent is a program that runs on each worker node to track its health and handle other management tasks. For this one also, you need to give some memory. Very good. SDFS cluster required master name node worker track data node. Your master daemon is called name node. Your worker daemon is called data node. Very good. Come back. Now, for Hadoop installations, Cloudera recommends that HDFS data nodes and yarn node managers run on the same set of worker nodes in the cluster. Data nodes require a basic amount of resources set aside for proper operation. Once again, data node requires a basic amount of resources set aside for proper operation. I'm highlighting this one. Now, HBase recommendations. If you have HBase running, considering that if you are going to use HBase, you have to dedicate some memory for HBase. When you are dedicating some memory to HBase, you will reduce some memory for yarn because you can't give whole memory to yarn. Okay, that's how it works. Next one, Impala. If you are using Impala, for Impala also you need to give some memory. This is nothing but everything I explained here. Everything explained here is written over here. That's the only thing. So I don't want to waste time on this one. Yeah, this is the important bit you have to understand now, guys. This thing and this thing is nothing but this Excel sheet. This Excel sheet I have very clearly explained, and I have already sent an email. If you have missed my email, you can find it here as well. github.com Hadoop ThoughtWorks materials page. I don't know how many of you have accepted, how many of you have gone through it. See, yarntuning.ppt uploaded, and yarn tuning guide.excel sheet. This is also uploaded. Okay, go and have a look if you want. Now, understand carefully, guys. Verifying yarn configurations in the resource manager UI. I'm going to explain it now, guys. Resource manager has a snapshot of available resources on the yarn cluster. I have to log in into labs.idiversity.com now. Is it visible to everyone now? Is it clear? Bhaskar, Suresh, is the font okay? Or do you want me to increase more? Now, guys, carefully observe. Let's open Yarn Resource Manager. Go to Yarn, click here, go to Yarn Resource Manager UI. Observe carefully. Observe carefully, everyone. Now, you have this much amount of memory used. Okay, you have this much of memory used. You have total this much of memory. Okay, containers running at the moment are 10. Applications completed is this much. Okay, there is a logical relation for you to show this one. Okay, let me show you that now. Your vCores used, your total vCores is 30. Okay, your vCores used is 10. Now, resource manager has a snapshot of available resources on yarn cluster. I showed you that. Example, assume you have following configurations on your 50 worker node. Yarn dot node manager dot resource memory MB means in megabytes. Your yarn node manager. What is node manager? Is nothing but your task tracker, worker node, or data node. In your data node, your yarn is having resource memory of 90,000 MB. Okay, your yarn node manager resources vCores. Understand something till here. Yarn node manager resources. Yarn node manager resources. Till here it's same. Here it is memory in megabytes 90,000. Here it's in virtual core 60. Okay, I'll show you that. I will show you the hell. Bale Babu. Come here. Go to yarn. Go to configs. Filter. Control V. Do you see that? Your yarn node manager memory given is 24 GB. Okay, and your percentage of physical CPU allocated is 80 GB, 80%, and number of virtual cores is 6. Okay, now understand guys, number of vcodes that can be allocated for containers, not for one containers. If you have 6 virtual cores, in that 6 virtual cores, number of cores that can be allocated for containers. Okay, now this is used by the resource manager scheduler when allocating resource for containers. This is not used to limit the number of CPUs used by yarn containers. It is set to -1 and yarn node manager resource dot detect hardware capability is true. It is automatically determined from the hardware in case of Windows and Linux. In other cases, number of vCores is 8 by default. When somebody asks you about capacity planning, when somebody asks you about performance tuning, all my students must be smart enough to answer these questions in the clever way. Wait, I want to copy this for you. This is nothing but the amount of CPU allocated for yarn containers, only effective when used with CG groups. CG groups nothing but cluster groups. Okay, now memory. This is the amount of physical memory in MB that can be allocated for containers. Okay, we are getting there. I want to copy this, man. I want to copy this. Hey, wait. Or else make a note of it, guys. Please make a note of it. It's not allowing me to copy. ఆడుకుంటుంది అది. స్క్రీన్ షాట్ కాదు, ఇట్స్ వెరీ ఇంపార్టెంట్ భాస్కర్. స్క్రీన్ షాట్ కాదు, ఐ వాంట్ టు రైట్ ఇట్. Okay, that's fine. Make a note of it. Quick. Guys, very important. I have been asked many times, can you tell me the establishment of link on how I can decide the virtual course? Tell them very clearly, boss, the number of vcores means that is the virtual course you give for your containers to launch. Point number 1. This is used by the resource manager scheduler when allocating resources. Point number 2. This is not used to limit the number of CPUs used by yarn. For example, if it is set to -1, okay, and if yarn node manager dot resource dot detect hardware capabilities are true, it is automatically determined from the hardware in case of Windows and Linux. In other cases, number of vcores is 8 by default. Make a note of it. Guys, 1 minute. Make a note of it. I'll come back in 1 minute. I'll go on mute for 1 minute. There is a okay. That's good. Now let's go to the next point, which is this one. Okay. Now try to understand something, guys. Focus. This is in MBs. This is in MBs. Okay. In GBs, it is 90 GB. Okay. You have 50 worker nodes. Okay. 50 into 90, which is 4500, which is 4.5 TB. That is your memory. Now you have 60 as a virtual cores. You have 50 node cluster, so it is 3000 virtual cores. Like that, here your total virtual cores is 30. Okay. Now go to host. 1 2 3 4 5 6 7 8 9 10. 10 node cluster. In 10 node cluster, if we have virtual cores 30, which means for each node, how much you have? You have 3. Is it? Am I right? Your virtual cores per node is 3. 3 into 10, 30. Here he has 3000 because 60 into 50. Here 30 divided by 10, 3. You understood now. That is virtual cores. Total memory. Here you have 128 GB. 120 GB, sorry. 120 GB for 10 node cluster means 12 GB per node. Okay. This is also understood. Very nice. Now let's go back. Yarn uses this is, I can't help this, I can't increase the font here, so because it's a slide, within the slide I have to allocate all the points. That's the reason it is there like that. Now Yarn uses this resource limit for allocation and enforces those limits for the cluster. Yarn container memory sizing. Guys, try to understand something very carefully. Maximum is yarn dot scheduler dot minimum allocation MB. Maximum is yarn dot scheduler dot maximum allocation in MB. Like that, you have yarn dot scheduler dot minimum allocation virtual course, yarn dot scheduler dot maximum allocation virtual course. Fantastic. This is about container memory sizing. I have to underline this actually. Okay, like that, you have yarn container allocation size increment. Size increment means yarn dot scheduler dot increment in allocations MB. Okay, like that, yarn dot scheduler dot increment dot allocation v course. Let me tell you, you need not have to by heart, or you need not have to remember all these things. You just have to understand they exist. You just have to understand how they work. You just have to understand how you can change the configurations. For example, if I copy this one, okay, and if I paste it here, I'll show you something interesting today. This is however hotter works, right? Let me show you how it looks in Cloudera also. See, allocation MB is 1024 MB, which is 1 GB. Try to understand here. The minimum allocation for every container request at the resource manager end in MBs. Memory request lower than this won't take effect. Means at least 1 GB must be given for each container, and specified value will get allocated at minimum. I'll show the same things in Cloudera. Bear with me. What is the time now? It's 6:12. I won't waste your time, don't worry. Okay, let it run. Meanwhile, what I'll do is I'll continue here. Okay, like that, if you copy this one, allocation virtual course, you'll get the properties. Very important. Try to practice in the home when you have time. Don't waste your time, guys. We are getting there slowly. Control A, Control V. See, containers. If I go here, yarn dot memory size container V course. Okay, this is also done. Now if I go here and if I go to slides here, yarn scheduler increment allocations in MB. Auto size increments mean how much do you want yarn to auto grow at the situations. At situations, how much do you want to grow? You don't have it here, but you'll have it in Cloudera. I'll show you that. Don't worry. It is launching. Okay, now restrictions and recommendations for container values. Here, what is trying to tell you is minimum required value is 0 for yarn scheduler minimum allocations MB. Any of the memory sizing properties must be less than or equal to yarn node manager resource memory MB. Okay, there is a link between allocations memory and this one. Okay, try to understand the link. Maximum value must be greater than or equal to minimum value. Okay, once again there is a link between yarn scheduler minimum allocations MB to yarn node manager resource MB, because maximum value must be greater than or equal to minimum value, that we know. Now virtual core properties also, there is a link between scheduler virtual allocation course to yarn node manager rows v course. Here also maximum must be greater than or equal to 0 or minimum value. That's what it is. Let's go to slide 13. Okay, map reduce configuration. You're almost done, bear with me. You're almost done. Map reduce configuration. In yarn, it is possible to do some easy misconfigurations. If the container memory request information is minimum sorry if the container request minimum is larger than memory available per node, then it would be impossible for yarn to fulfill the request. I'll show you that practically. Okay, let me check if my yarn is launched. It's launching. Very good. I appreciate it. Close this one. Go to CloudRAM Manager. It is launching. It will take some time. Don't worry about it. Guys, understand the point here. It is possible in yarn to do some misconfigurations. How? For example, yarn scheduler memory allocations in MB, okay, is larger than memory available per node. Okay, for example, in your node, if you have 8 GB of RAM, and if you have yarn scheduler minimum allocations which is greater than 8 GB, then it would be impossible for yarn. Okay, so your yarn scheduler minimum allocations must be less than yarn node manager resource MB. So for example, if your cluster is 8 GB, definitely you will not give all the 8 GB to yarn. You will give 1 or 2 GB. In that 1 or 2 GB, you give something to your schedulers, not the whole. That is the reason why your scheduler memory allocation MB must be less than yarn node manager resource memory. Very good. Now, next point is the map task memory property, which is mapreduce.map.memory.mb. Okay, and the reduce task property is mapreduce.observe carefully. mapreduce.map.memory.mb. mapreduce.reduce.memory.mb. Here it is map, here it is map, here it is reduce. Now, since both types of task must fit in a container, the value should be less than the container's maximum size. If container's maximum size is 2 GB, your map reduce memory your map must be 1 GB and your reduce must be 1 GB. But combination of map and reduce must not be greater than the maximum container size. These are the basic recommendations. When you tell in the interview very clearly, they'll be very happy because they'll come to an idea. Yes, you have the core. I'm stopping and starting it just to make sure it starts up. We are done, guys. Don't worry. I'll finish it in the next 5 minutes. I'm explaining slowly. That's the reason it's taking time. Very important. This one is very important throughout your Hadoop administration life because you're understanding how each and everything works and how you can improve the performance. You will not find it anywhere. Trust me. Now, if you see here, like that, special case is application memory and memory configurations. Let me understand that. Let me explain you that. The property yarn.mapreduce.am.resource.mb is used to set memory size for application master. Since the application master must fit in the container, the property should be less than container maximum. Very good. Scheduling yarn. The resource manager tracks resources on the cluster, assigns them to application that need them. The scheduler is that part of resource manager that does this matching, honoring the organizational policies. Please note that yarn. One second, guys. Sorry for that. Please note that yarn uses queues to share resources. Yesterday we spoken about queues. I'm going to explain that queues now. The application master tracks each queue's resource requirement and coordinates the container request. This approach allows better scaling of resources. Look at this one. Now, look at the phase scheduler. Guys, understand. See, Figure 1 presents a basic phase schedule example and a graphical representation of each queue share of cluster. There are 4 departments: marketing, sales, data science, admin. Okay, there is a special admin queue that uses Fred or Greg. Okay, I have to explain it very nicely. Bear with me. Don't pressurize me that time is going up. I can't help because these are the important concepts. It will take time. People who are getting late can go. No worries. It will be done in the next 5 minutes. It's just I have to explain very nicely. because it's very important. If you don't understand this, there's no point of me spending time yesterday's class. Okay, let me take a pen here. Okay, this is done. And let's say 1 minute, guys. Okay, now observe carefully. Guys, observe carefully. This is marketing. Share is 30. This is sales. Sale is 20. This is data science. Sale is weight is 40. Admin. Within admin, within admin, you have weight of 10. Okay. Now, please focus. Please focus. There is a special admin queue that users Fred or Greg, who are assumed to be administrators, can use. Now, what you have to understand is, if you are a database, what happened? Somebody's pinging. Guys, is the problem with everyone? Can't you see the marker? See, I'm doing something here. Can't you see this? Guys, please respond. Can you see something which I am marking on the screen?
No.
No.
Others, do you see that I'm marking something now? I'm writing some shit on the screen. Nobody? Okay. Let me stop sharing and try again.
Yeah, Amar, we can see now. You've written something.
Some garbage. You can see it, right?
Yes. Yes. Now we can see.
Okay. Very good. Very good. Let me clean that up. Okay. Now tell me if you are able to see or not. See, this is marketing. Okay. The weight given for marketing is 30. This is sales. Weight given to sales is 20. This is data science. Weight given to data science is 40. Okay. Cool. Yeah. If you're able to see, I'm happy. Don't worry. Yeah. Okay. Cool. Okay. Now let me open the PPT. Okay. Within that you have admin. Now try to understand. You as an administrator, you will have full privileges when compared to other queues. That is the reason why there is a special admin queue that uses Fred or Greg, who are assumed to be administrators, they can use. Okay. Now what important thing is, yesterday's class and today's class, you must be able to establish a link. Okay. Now this is admin, this is sales, this is marketing, this is data science. Among them, they have got more share. These guys have got more share, and the second share is given to these guys. So whatever the jobs data science team submits, priority 1. Whatever jobs submits by marketing, priority 2. Priority 3 will be sales, priority 4 will be admin. Now, whichever scheduler you are using, based upon the weight you gave to each group, they will be prioritized. That is nothing but queues are the organization structure of yarn schedulers, allowing multiple tenants to share the cluster. As applications are submitted to yarn, they are assigned to queue by scheduler. That's true. Which queue is that? Marketing has their own queue, they don't share. Data science has their own queue, they don't share. Sales has their own queue, they don't share. Admin has their own queue, they don't share. That's how it works. Okay, clear everyone? Understood this concept? Guys, respond fast. Is it clear to everyone? Perfect. That's nice. That's good. I appreciate it. Let me clear the drawings. If you don't understand, just give me a shout. I'll approach a different way. Don't worry about it. This is done now. Let me go to second one. Go to second slide. If you observe this slide carefully, guys, now one level of queue allows sharing the cluster among the dimensions, but it is common to share cluster among multiple dimensions. Multiple dimensions is nothing but within the root. Let me take a pen again. See, within the you see you within the tenants you have multiple tenants. In North America, Europe website reports. In North America, you have sales again. Okay, this one, a tenant inside a tenant. Website and reports, you have other thing here. Okay, in data science, you have root again. Okay, short jobs. In such situations, let me clear the drawings. Let me go to pointer. Now observe carefully. Understand the concept. Now, File scheduler allows nesting queues to form hierarchical queue structure where each level could correspond to dimension under the parent queue. Okay. Here, figure 2 below shows resources shared among team and priority dimensions. The first level corresponds to team data science, and each first level queue could have a high priority and low priority. You can decide like that. Okay. Look at the weights they have given. Based on the weight, it goes. Okay. Look at the marketing queue. I'm jumping here. In the marketing queue, there are two child queues, which is reports and website. This means that job in the reports queue are allocated twice as many resources as jobs in websites queue. However, together their weights will be still governed by the marketing queue weight. It is nothing but how effectively, how differently, how vertical tenant wise, horizontal tenant wise your cluster can distribute the resources and make use of them. Okay, one more slide left. Bear with me. Okay, don't worry about this one. This is simply a queue property, how a queue can work, how you can share the resources with them. Okay, this one is the queue replacement policy. If queue is applicable, do this one. If queue is not applicable, go back and see the configurations. That's all I have for today. Now let me show you two things in Cloudera. Okay, I try to show you there, right? Now copy this one. Okay, go to your Cloudera, click I agree, click login. Try to understand the difference between Cloudera and Yarn Hortonworks. They both are same. There's no big difference. Now go to, where is your Yarn here? Go to your Yarn. Okay. Go to your configurations. Okay. In your configurations, go and search. It is loading up. Give me a minute. Here search. Control V or paste. Click enter. Okay. See your Yarn node manager resource MB here is 3 GB for this cluster. Okay, now go to your this thing, check here, see the difference. They both are same, guys. It's just a UI difference. And see here it is 24 GB for Yarn memory allocated for all. Yeah, I'm sorry, memory allocated for all Yarn containers on a node is 24 GB. This is in Hortonworks. What I'm trying to understand is understand the UI difference. This property I can change it. See, if I go like this, I can change it. If I move right side, I can change it. It's not a big deal. Like that, look at here. I can change here. I can change 8 GB, 5 GB like that. Okay. For example, it's 3 GB, right? I'll change it to 2 GB. Understand. Focus, guys. Focus what's happening. So, understand here. If I say 3, here it's not highlighted. Save changes on the bottom is not highlighted. Do you see my cursor, everyone? Do you see my cursor? Save is not highlighted because I have not changed it. If I say 3.5, it is changing. Do you see here? Save changes came to blue color. Now I will save changes. Okay. I clicked on save changes. Now see what happens. Now see what happens. Do you see here? Stale configurations restart needed. Means, idiot, you changed from 3 GB to 3.5 GB. For this changes to take effect, I need a restart. Click actions. Okay. Then click restart. Okay. It is telling, boss, are you sure you want to restart Yarn? If you restart Yarn, these are all dependent with Yarn. This will be restarted. Restart. Okay. Here, if I go here, and if I can't change this because I don't have permissions. If I'm admin, I can change it. Okay. If you go on Yarn, okay, here also I couldn't see any restart. If I'm admin, I can clearly see a restart here. Okay. Here you'll have an option, restart option. See, it is starting, it is stopping. That is the UI level differences between Cloudera and Hortonworks. There's no big difference apart from this one. Time is 6:31. Yep, that's all I have for today. Any questions? Let me know. It's a very important concept. I'm sure even though you will not find this level of performance tuning anywhere. If you understand this one, this will help you this will help you in your capacity planning as well. Capacity planning, performance optimization, both. Any questions, anyone? Okay, guys, let's leave. If you don't have any questions, I'm fine. If you have any questions, let me know. It's a very important concept. I expect you should give at least 2 or 3 questions looking at the criticality of the why are why are we going to Autonomous instead of Cloudera? Which phone are you using, sir? Which mobile phone are you using?
Samsung.
Samsung. Why are you using Samsung?
I think it's user friendly compared to iPhone.
For me, iPhone is friendly, sir. That's the only thing. Every business has their own pros and cons. Some people like Hortonworks. Some people like Cloudera. Bankings are with Hortonworks. Insurance, retail, telecom are with Cloudera. Some banks are with Cloudera, not all the banks. Some banks are with Cloudera, some banks are with Hortonworks, some retail are with Hortonworks, some retail are Cloudera. However, Cloudera market is very big when compared to Hortonworks. Cloudera started from 2001 to 2004, whereas Hortonworks came in 2010 to 11. Their Hortonworks is backed up by Yahoo, and Cloudera is backed up by a guy called Doug Cutting, who is the founder of Hadoop. Okay, that's the only reason, sir. The way you are comfortable with Samsung, the way I'm comfortable with iPhone, it's just a business decision, and their marketing strategy or their business enterprise partnership, the relationships is all that matters.
But some features will be there, right, compared to Cloudera or Hortonworks.
Okay, first thing is Hortonworks have their own component called Tez, which runs
Sorry.
on top of MapReduce. Okay, TEZ, Tez. Let me show you that. Oh, I closed it, man. Shit. That's okay. You'll find it in your. I will find it in your Ambari. Go and have a look.
Okay.
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 And this one, if you see Impala, Impala is a Cloudera's query engine platform on top of your HDFS. You won't see Tej in Cloudera. You won't see Impala in Hortonworks because Impala is their this guy's product. Tej is their product. Like that, there are one or two products they have built by themselves. Clear?
Okay. Clear.
Anything else?
అలానే అలానే ఇంకోటి CentOS, Ubuntu, Red Hat. Some companies using CentOS, some companies are using Ubuntu or Red Hat. What is the main purpose they are using for CentOS instead of going for Ubuntu or Red Hat? Is
Center,
there any unique features or the?
no, sir. Ubuntu CentOS is also RHEL, Red Hat Enterprise License. Okay,
Okay.
90% of productions will be on CentOS. Your development test proof of concepts will be used with Ubuntu. Okay, if you see all, if you see all the virtual machines will be Ubuntu only. Production will always be CentOS because of the flexibility, because of the consistency, because of the support, because of the Red Hat's licensing, all these things. Clear?
Yeah, fine. Thanks.
Anybody else? Any questions? Okay, guys, have a good day. Please kindly complete M repositories and also this video. Sunday morning, we shall catch up for HDP cluster configuration. Okay. Thanks. Have a good day.
Yeah.
Have a great weekend.
If this won't exit properly, it won't be converted now. That is a big issue. I need to come out close carefully from this one. Yeah, now this is fine.